Hey everybody, Jason here at GD&T Basics with today's video question line. Today's topic is profile of a surface versus profile of a line. Today's question submitted was, what will be the permissible difference in the dimensions of objects with the same value? For example, 10 thousandths of profile of a line versus 10 thousandths of profile of a surface. Let's take a look at a couple examples and compare any permissible differences. So right out of the gate, we see the left example controls the top surface with profile of a surface, and the right example controls the top profile with profile of a line. So profile of a surface will control the entire surface to one tolerance zone, whereas profile of a line controls any linear element represented in that view. So this linear element right here, again, it's any linear element, so this one or this one or this one to the tolerance listed. So profile of a surface is going to create two parallel planes, since we're controlling a planar surface, as the tolerance zone, and the surface needs to exist inside those planes. However, you'll notice we don't have any datums listed at all, and so that means if the surface exists at an angle, our tolerance zone can shift to an angle to capture that surface. It's not with respect to any other features. This tolerance is to itself only. So basically this is flatness, but we can apply profile of a surface as well as profile of a line to irregular features, right? So we can apply this to the same way, and the tolerance zone, if it were an irregular feature, the tolerance zone would mimic that irregular feature. And again though, that tolerance zone could move in location or orientation in any direction to capture that surface. We're just controlling the form. Profile of a line, however, is controlling any linear element to the tolerance zone. So if we're looking at this linear element from the front face here, we see that linear element exists like that, and we are controlling that linear element to a two-dimensional zone. So that means that this linear element, as it goes down this direction, can go up or down, right? And has to stay inside this tolerance value here. But this linear element, if we were to check one over here, could exist way up here. And all we're doing is checking to make sure that linear element is inside its own specific tolerance zone. So that surface, as it traverses this way, can look pretty wavy, and it will pass all day long for profile of a line. So again, it's a very unique control to only control the form along one direction, but it's any given cross-section disassociated from the adjacent cross-sections. So again, very unique control. Not many situations are utilizing profile of a line. Most often than not, we care about the entire surface simultaneously. But let's take a look at this next example here. And we see that we have profile of a surface on the same part, but now referenced to datum A. Referencing it to datum A means that this tolerance zone now is locked, centered at true profile, and that is parallel to datum feature A and 1.5 inches away from that datum plane. And so now the surface has to be inside this located and orient tolerance zone. So the surface can have bad form error and go up at an angle, but it has to be inside this zone. Subsequently, same thing for datum feature A over here. Datum feature A is being referenced on profile of a line. And that means for this linear cross-section here, if it exists right there, well, that now is located to datum A. So our tolerance zone here is still 0.010, and the linear element needs to be inside that tolerance zone, but the adjacent element also is located to that datum as well, and so our tolerance zone is the same. So if we consider all of the elements together, it really is the same interpretation as if we were looking at profile of a surface. So in this scenario, there really is no permissible design difference between these two setups. This will restrain all elements of that surface, cross-section at a time, to no higher than 1.5 plus 5 thousandths or minus 5 thousandths, as well as the orientation. And that is exactly what's happening here as well. So when datums are involved, things get a little bit trickier. The permissible difference might not be any different. It just depends on the datums referenced and if there are datums referenced. So hopefully that answers your question and sheds some light on the issue. Thanks for submitting.
Our goal is to be your best source for GD&T information online. It's important to us that everyone involved in engineering and manufacturing have the chance to learn and better understand GD&T on your prints. We have many free resources to help you get started on your learning journey. Subscribe to our GD&T community using the link in the description below or visit our website. Test your knowledge with our GD&T and print reading quizzes. Download helpful charts and access articles written by our training experts.